Within our communities, there are many children that suffer from mobility impairments, the most common type being cerebral palsy. Cerebral palsy is a disability that impacts the muscles of the children, prohibiting them to perform simple motor functions such as walking, tying their shoes, and eating. Cerebral palsy is characterized into 4 types. First type being ataxic, where the kid gets tremors when doing voluntary muscle movements. Athetoid, where the kid cannot control their movements. Mixed, which is a combination of any of the 3 that are shown here, as well as spastic, which is the most common type, an estimated of 70% of all cases, and this is what our project is based off of. Cerebral palsy is then further broken down into stages. The first stage is where the child shows little to no symptoms. Stage 2 is where the child can walk in most settings, but generally needs assistance with a walker when they go from A to B. Stage 3 is where they walk comfortably with a walker inside, however needs a wheelchair to do long distances outside. Stage 4 is where they can walk very short distances and generally uses body support walkers and wheelchairs. Stage 5 is where they need full-on assistance to get from A to B. It is estimated that 1 out of 345 children are diagnosed with cerebral palsy globally. Not only does cerebral palsy affect the child and their interactions on a day-to-day basis, it also has a huge impact physically, emotionally, and financially. Here's a cost breakdown of the yearly healthcare costs for children in Canada from birth to 19 years of age. Imagine if you were a parent and you could not teach your kid how to walk, how to skate, or even bring them to the park for a game of catch. Not only does this impact the relationship you would have with your kid, this would also impact their social life, and they would lose out on the viable skills necessary for us to build relationships as adults. Cerebral palsy impacts the lives of every individual involved, and having a tool that would allow your child to do the activities that every child has a right to, it would also provide you with the ability to take your kid out to the park for that game of catch. Our overall objectives were safety, performance, appearance, and costs. For safety, we wanted a walker that was not only safe for the user, but also safe for the environment. In appearance, we wanted a walker that was easy to use, easy to maintain, and convenient for the operator. For appearance, we wanted a walker that looked premium and was comfortable for children. And finally, we wanted a walker to have a low overall cost to support families in need. For our solutions, we followed the rigorous design process, starting with research and ending with improving on what we had found. For our first solution, was a simple design and was easily manufacturable. However, its simplicity was its downfall in overall structural integrity, and we deemed it unsafe. So we went back to the drawing board and we researched a better design and imagined a better design. For this solution, we used the first solution as our base and added extendable handles and made an overall stronger design. However, the amount of material and the cage-like feel and experience drove us away. So we went back to imagine and came up with the Airwalker. For the Airwalker, we created a prototype which used less material than its predecessor, was more structurally sound, and was an overall better appearance. The dimensions were chosen based on researching the average heights and dimensions of the children. The width was set to 1.5 times that of the shoulder width. The height is just above waist height for comfortability, and the length was chosen to help the kid not feel so encaged from their surroundings. Prototype, we chose to go with wood. This was due to the limited resources and finances that were available to our group. We were able to build the prototype almost identical to the 3D model that was created. The dimensions and look of the design that we have in front of you mimic almost every aspect. Here we have a function overview going over each function that the Airwalker can provide. In SOLIDWORKS, we built the frame out of aluminum alloy, which is a cheaper, robust, and a well-rounded aluminum. Created a detachable basket to allow children to pack around their toys, which can also be easily removed if not needed. We added 2 rubber stoppers and grips to provide comfort and safety for the child. Added 2 braces, a seat, and a hinge so when the child is tired they have a place to rest. Finally, we added 4 wheels that swivel in all directions, made out of rubber to roll in rough terrain, and 2 that have locking mechanisms for when the chair is being used. Due to the lack of resources and limiting budget, we built our prototype out of wood. This allowed us to mimic almost every aspect of our CAD design. We added 4 wheels that swivel in all directions, 2 of which have locking mechanisms in the front for safety. We also added cloth wrapped in duct tape to mimic the rubber grips and stoppers from the CAD design, as well as we have a foldable chair that folds with a hinge and is attached by Velcro. And to top it all off, we have a detachable basket in the front, which is able to hold the toys for the child. From this video, you could see that the walker is very stable when the wheels are locked, and it can sustain a weight of greater than 175 pounds. As you can see, the chair holds my weight, and now Braden's going to take it away with the economical considerations of this product.
Some design concerns we had to address when designing our walker. The first of these concerns was safety, which was of utmost importance because of the walker's purpose being a medical device, so it being unsafe would be counterproductive. The first way we addressed the safety concern was by making the walker out of aluminum. That way, the walker wouldn't collapse under the weight of the user and cause serious bodily harm. The second way we addressed this concern was by making sure there were no pinching, cutting, sharp edges, no kind of hazards like that, so that the user wouldn't be brought to harm by the walker itself. The third way we addressed this concern was by making the wheels all-terrain, so that whatever conditions are, the user could use the walker without there being any chance of the user being endangered. The final way we addressed the safety concern was by adding a locking mechanism to the wheels. That way, if the user was on a steep hill, the wheels wouldn't roll into them or make the walker roll away from them, so they can be either injured or stranded by the walker. The second concern we had to address was that of an environmental concern. The first way we addressed this environmental concern was by using the aluminum. We could melt it down so that that material could be reused in something else instead of just being thrown in the garbage. The second way aluminum helped was by being a long-lasting material, unlike something like plastic, so that it could just be used constantly and not have to be replaced every so often, and the expired material had to just be thrown in a landfill somewhere. The third way we addressed this environmental concern was by making the walker so that it could just be given to charity afterwards, so that if you were done with the walker, then somebody else could use it instead of another walker having to be made for that person. The third concern we had to address was that of an economic concern. The first way we addressed this was by making sure enough of the parts were similar to each other to reduce the price of the walker. And the second way we addressed this was by making the walker out of aluminum instead of an overly expensive material like titanium, for example, so that it wouldn't break the bank if the user needed to get a new walker for whatever reason. The final way we addressed this economic concern was by making the wheels easily replaceable, so that you wouldn't have to take it in for repairs if one of the wheels broke for whatever reason. You just attach a new wheel. The final concern we had to address was a societal concern. How would this affect the greater society? The first way this is addressed is through the walker's function itself. This gets more people able to move around and interact with the world. The second way we address this in societal concern is by adding a basket onto the front of the walker. That way, users with cerebral palsy could more easily shop and go about daily lives and carry objects without having to need someone else to help them out or support them. That's been all. Now I'm going to send you over to Tazreen to talk about some final points.
The color of the walker is made blue because of the highest percentage among all the colors as shown in the result of the survey. And the basket attached is red as it is ranked second, and also to make the walker colorful and attractive. A harness seat could be attached for future development of the design. The harness seat can be included for the children suffering from stage 4 and 5 of spastic cerebral palsy, which is the most severe form than stage 2 and 3, and thus need support for them to stand. Considering the requirement, safety, constraints, environmental and economical issues, our design is the walker for children of 2 to 3 years old suffering from spastic cerebral palsy stage 2 and 3, where they do not need harness support in order to travel. The height of the walker is 76.10 cm and the width inside the walker is 36 cm. Braking mechanism in the wheels to ensure safety of the child. The walker is also very cost effective because of same dimension on either side. The number of cerebral palsy should not be underestimated. With proper information, care, support, people with cerebral palsy can lead a productive life. Thank you very much.